Okay, so our last transformation is a dilation. So a dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed point C called the center of dilation and a scale factor K, which is the ratio of the lengths of the corresponding sides of the image and the pre-image. So scale factors are written so that the units in the numerator and denominator divide out, meaning that a scale factor is going to have no units. And a dilation is a rigid motion, is not a rigid motion. Excuse me. Okay, so a dilation is not a rigid motion. So keep in mind that a rigid motion means that all side lengths, all angles, all of that stuff is preserved. And with a dilation, that is not the case. So a dilation with center of dilation C and a scale factor K will map every point P in a figure to P prime so that if P is the center point, then P is equal to P prime. So if we're dilating it with respect to P, then P and P prime are going to be the same thing. If P is not the center point C, then the image point P prime will lie on the ray CP, and the scale factor K is a positive number so that K would equal CP prime over CP. So the distance of C to P prime divided by the distance of CP. So it's either going to be getting bigger or it's going to be getting smaller. And all angle measures are preserved. So a dilation will not change any line that passes through the center of dilation. A dilation maps a line that does not pass through the center of dilation to a parallel line. So in the figure above, we can look at some parallel lines that we have here. So PR, this guy, is parallel to P prime R prime. PQ would be parallel to P prime Q prime. And then RQ is parallel to R prime Q prime. So all of these things are parallel to each other. However, they are not the same size. So when the scale factor K is greater than 1, the dilation will be an enlargement. So it's getting bigger. And when K is between 0 and 1, of course not including 0 or 1, it would be a reduction. So it'd be getting smaller. So we also have some rules for dilations in the coordinate plane. So if I'm taking the point XY, that would be our pre-image. Then the image after the dilation, saying that it's being dilated with respect to the origin, or 0, 0. It has a scale factor. It's going to be moved or dilated to the point KX, KY. So it's actually going to be multiplying whatever the scale factor is by X and Y. So unless otherwise noted, all of our dilations in the coordinate plane will be with respect to the origin. Now it is possible to have a negative scale factor. So in the coordinate plane, you can have scale factors that are negative numbers. When this occurs, the figure will rotate 180 degrees. And then when K is greater than 0, a dilation with a scale factor of negative K. So again, K itself is bigger than 0, and we have a negative value. It's the same as the composition of a dilation with a scale factor of K followed by a rotation of 180 degrees about the center of dilation. So you can see the picture over here. We're starting with this blue pre-image. We use the scale factor of K to enlarge it or reduce it, depending, and then we rotate it 180 degrees. So it's down here now. So notice that it's reflected over as well, and it could have been translated instead of having that rotation. So using the coordinate rules for a dilation and rotation of 180, we take this point of xy, it gets moved to kx, ky, because that's the dilation, either getting bigger or smaller, and then they both become negative because it rotates 180 degrees. So if you wanted to play around with this, you could see which of these has a negative rotation, which of them has a positive rotation. If there's a dilation, that's an enlargement or a reduction. So you can play around with all of those if you'd like. And then note, in all dilations, notice the relationships between the lengths and slopes of the segments and sides. Each segment should be changed relative to the corresponding side by the scale factor. So for example, this one is 3. So this one is 3, 6, 9. So it's been expanded by 3. K prime, L prime is 1, whereas this was 3. So I'm getting smaller by a factor of 3. Everything is being changed. The corresponding sides are parallel because their slopes are the same. So it's being moved with respect to that vector.